Hello.
Hi, Lavanya.
Hello. Hello, everyone. So let's give one more minute. I think we can get started. I think in the last week, we have covered services and then the pod probes, and then we have seen what will happen if the application fails. So mostly we have seen the pod statuses. Yeah. So let me ask few questions on that. So what are different types of probes that we have in Kubernetes? Yes.
Readiness probe and liveliness probe.
Yes. So what is the use of liveliness probe?
If the container is not in the ready state, then it will restart the container by doing the health check.
Okay. So basically it will restart. So it will give a resilience for your application. If something happens, if some crash happens, it will automatically restart based on the probe configuration that is being set in the liveliness probe, right? And readiness probe?
If the probe is not yet ready, then it will remove those endpoints from the service.
Yes, traffic will not be allowed to that pod. So in whichever container readiness probe fails, it will be removed from the traffic. I mean, it will be removed from the live endpoints. So that pod endpoint will be removed. Yeah. So there is a third probe that is available, which is called startup probe. It is also similar to these two probes. The only thing is it will be checked only on the startup of your application. For example, if you deploy your application, it will take some time to start the application. For example, I have a database application. So my pod is a database pod. So it should take quite some time to start. So in that case, we can configure startup probe. So basically, if for a long starting application, we can configure startup probe. So once that startup probe succeeds, then only these liveliness and readiness probe will come into picture. So every time when a pod is deployed, this startup probe will come into picture. The setting is all same for rest of the probes, how it is. It is exactly same, similar to your liveliness and readiness probe. The only thing is it will be checked at the startup of your application and delay other probes. So after this probe only, other probes will come into picture. Okay. And then what are the methods that the probe can check?
HTTP, exec, and TCP. Yeah, TCP.
Yes. So these are the probes, commonly used probe to check the health check. So basically, you have to pass in a path and port to check these probes. So these are the configuration that we have to pass to ensure that your application is up and running. So any questions from the last session? Okay. Then I think we are.
Yeah, Lavanya. So
Yes,
during the load generation, like I didn't join 4 sessions. I went through the recordings from last 2 days. So during the load generation, I see a message called deleted pod during the load generation step once we run, when it generates the load. It says like it has deleted a pod or something. So is that on a purpose, or is that written on your script when we run? When it runs the iteration, it does some deletion.
Which pod you mean? So basically, we injected few load to ensure HPA was working. That's what you
No,
were saying.
actually, we'll create a busy box container, and if we get out of it, we'll be terminating, right? -rm will be giving it to delete. Maybe he's referring to.
Okay. So basically, so you'll have to generate a load within your application, right? So how we generated the load, we spinned up another pod within the same cluster. And then once you get out of that load generation pod, it will be automatically deleted. The pod will be deleted because no longer we need that pod, right? So we are removing the pod once after doing the load test. Is that what you're saying, Abhishek?
Yeah, like I just saw a message once we run this step, like for the test connectivity step in the README, right? So while I was executing, I saw that message.
Yes.
So that's why I was confirmed. Like
you can run the deployment forever, and also you can do just in it is like a point in time testing. So on that timestamp, we create a pod and then generate the load to the application that we are expecting to scale. And then while executing the load test, we'll remove the container. Unnecessarily, why will we keep the container in terminated state or in failed state? So we'll just remove the container as soon as the load generation is completed. So yeah, thank you, Poluka, for finding out.
Yeah. Thanks.
And I have a doubt, like in HPA, we'll be giving the behavior. In that, we'll be mentioning the stabilization window period, right? So even though the load has been increased to a certain amount, whatever I have mentioned, after that, though I mentioned it as 0 during the scale down, but still it took a certain amount of time to scale down. Does it depends on the policies as well, or will it just take the stabilization window period, and how the policy and stabilization window works is my question.
Yes, scale up and scale down stabilization window. So how long it will take, right? So you have not paused in any setting for scale up and down. Is that right, Poluka?
I have kept the stabilization window as 0 actually. Let me paste that as well.
So basically, it will not just like that in 0 second, it will not scale down. So it has to calculate the average.
I mean, beside capacity.
So for example, you are scaling up your pod based on the CPU, right?
Yeah.
So for example, your CPU is 80%, but you have configured to scale up at 90%. So it will have to calculate the average of all the pods that are currently running. So based on that, it will schedule. So once it reaches that 90%, then it will have to wait, like how long it can withstand at 90%. You might have configured scale up stabilization window as well. So in that time frame, it will wait for few seconds. So by default, it is 300 seconds if you don't configure anything. So basically 5 minutes is the window. So it will take to check the average, and then it will continue. It has to continue on the same state for 5 minutes by default. Then it does the scale up. Same goes for scale down. So let me check your configuration.
Yeah.
But you cannot expect to scale down in 0 seconds. So that's
Not like 0 seconds, but it took like almost 1.5 minutes to 2 minutes, something like that.
okay. Just a minute. Stabilization window seconds. Okay. So you have mentioned the scale max policy also.
Yeah. I mean, like in both of these policies, it will select the max one, right?
So policy quad value 1 period second 15 and percentage is, so 50% is your, okay.
I have a screenshot as well. Can I share my screen and show that?
You can.
So yeah. So here if is 1 minute, yeah. So here 50%, so it came to 54.42. Till then these are 3. Unless until it is like 1%, I mean like 1% of it, then it came to 2.
Okay. So your scaling percentage is 50%. Is that right?
Yeah.
And then so when it was 50%, it was on the same, it has to be on the same number of plus. Then it has to reduce to scale down.
Scale down, yeah.
So this time frame starting from 39 to 1%, you are saying that it is taking more than 1 minute.
Yeah, almost like 1.5 minutes, something around like that.
Okay. So it's not only based on the stabilization window, the HPA controller itself will run 15 seconds once.
Yeah, it will be in the default controller settings, right? So for 15 seconds, then it has to change the replica count.
So immediately you will not expect. So by default, there is a delay, 15 seconds, and also your cube state matrix is there, right? Cube state matrix is the one that collects your CPU and memory data, right?
Oh, yeah.
So because there is also a delay. So how long? Because we are using kind cluster in our case, right? So basically what it does, we have deployed the metric server. The metric server collection has some interval. So it collects the CPU and memory, and then it passes on to the metric server. The details that the scaling that happens is based on the data from the metric server. So there you will definitely see 30 to 60 seconds of delay. So basically there will be a time lag will be there. Not like, it cannot immediately scrape it and then send it to metric server. So there will be definitely at least 30-second delay will be there at the metric collection level and also this HPA controller level. So that's why you are seeing a lag there. But yeah, basically this HPA usually in production, what they will do, at least 5 minute stabilization window as a best practice we should have, because sometimes there can be a load for the application, so it can go for just for 1 minute or 2 minutes. So you don't need to scale for that 1 minute to address the traffic. So it will withstand. So maybe some slowness will be there, but it can withstand such traffic. Such small spike of traffic is allowed. It's fine. But for a long running load only, we'll have to do this scaling. So real use case will be at least 5 minutes or 10 minutes. So then only your application will experience slowness, and then all stuffs will be there. So always by default, it will be configured for at least 5 minutes. So that's the realistic time that I would say. Sometimes the scale down window, scale up is fine. Scale up can happen as soon as it checks the metrics. But scale down, it's fine. It can scale down in a delayed period. Because if we scale down in just 5 minutes, and then if there is another spike that happens, because during the load period, we cannot expect that it will go down and it will go to 0. We cannot expect such scale down behavior, right? So what we will do, scale down behavior, they will keep at least 15 minutes. So let it run for 15 minutes and then do a scale down. So the scale up has to be faster always, and the scale down can be slower.
Okay. Yeah.
Okay, that's how the production systems work.
Yeah. Thanks, Lavanya.
Okay, good that you are going through. And I also appreciate everyone to go through the labs. Again, if you are not doing it in the live session, just go through the labs and then try yourself some scenarios that are given in the lab, and also you can explore more. So we are giving all the details where you can explore for other questions, other labs. You can just explore the other parameters and then explore yourself with the kind cluster. So you have all the setups, and every day labs are also given, so you can explore further yourself, okay, and come up with questions so that it will be helpful for you as well. Okay, so with that, we can start today's session. Let me share my screen. Hope my screen is visible.
Yes, it is.
So today is week 4. Okay, sharing the week 4 content already. And then let me start my slide. Yep. So today we are going to see the most important concepts in Kubernetes, which is storage and role-based access control. Let me. Yeah. So why do you think we need storage in Kubernetes? Because we have pods, and it can restart if there are any failures. So all the problems are solved then and there, right? So why do you think we need a storage?
For the data persistency.
Okay. So exactly as you said, we definitely need storage, even though your applications are not stateful. Okay. For stateful application, you must have a storage. That is for sure. So what is the reason to have a storage in stateless application? For example, deployment, I mean. Stateful set is stateful for applications, and for stateless, it is deployment. Okay. So why do you think that we need a storage in deployment?
Suppose the pods are destroyed, so our data will lost, so that's why we need some volumes.
Right. So basically, you need all the logs to be stored, right? So every application will definitely generate some logs. So those logs need to be stored somewhere. At least until it is shipped to some monitoring solution, it has to be stored somewhere. So that is one use case, but there are a lot of other use cases as well that we will see. So basically for logs, for database files, so for short-term storage, we'll have to use some data persistence. So that's why we need storage in, even though for stateless applications. Okay. With that, I think we can start with the agenda, what we are going to see. So we are going to see volumes, persistence volumes, what's persistent volume claim, what is storage class, and how it is used in Kubernetes world. And then moving on to the RBAC session, we will see what is role binding and cluster role binding, and what is the difference between these, and then when to use what. So these are the agenda that we are going to look at today's class. Okay. So as we discussed, why do we need storage in Kubernetes? So these containers are ephemeral. It can be lost at any time. So whenever a pod restart, container is recreated, right? So a container is recreated, the previous container is already lost. So the data in the container is gone. So that is the problem. So every time it gets restart, we lose the data. So in order to persist the data, we'll have to have some kind of storage mechanism. So that is provided by these storage solutions that we have in Kubernetes that we will see now. Okay. So that's the use case of having a storage in Kubernetes. So let me okay, so we have a pod, and then when it restarts, we lose the data which is there in the pod, in that container. So basically, pod will have a container, and then container will generate some logs. Those logs will be lost when a pod is restarted. So in order to keep the data, so we need to introduce a concept called storage. Okay. So basically, how we will do, it's fine. So basically, we'll introduce concept called volume, and this volume will be attached to your pod. So that's how we are solving this problem. And then let me show you how it is exactly done. So basically, how the storage will be provisioned. So we need to have a physical storage. So how this physical storage will come into picture? We have virtual machines, right? So those virtual machines will have some storage. So we'll make use of such storage, and then so we cannot just like that consume all the VM storage for a single pod, right? So we'll have to create a volume under some specific size. So that is called as your persistence volume. So your actual storage is on your virtual machine, and then you are consuming it by creating a volume on that machine. So each and every machine will have some storage capacity, and then it will you are just making use of it by creating the volume. Okay, so that's how we will create the volume. That's the actual storage. This persistence volume is your actual storage. So what are different types of volumes that are available in any virtual machine? Any idea? So if it is just a virtual machine, you will have a local disk for that virtual machine, right? And if it is a cloud-based machine, then you will have, for example, if it is an Azure, then Azure disk will be there. So Azure disk will be your volume. And then if it is an AWS, you will have AWS EBS as your volume. And then NFS, your the most famous one for your storage. So, yeah, so these are the actual storage types that are available. So for our labs, we are going to see the local disks that are available in the VM itself. So basically, in our kind cluster, it will be on the Docker container. Okay. So your actual volume is your persistent PV, persistent volume. So that's your actual storage. But there is another concept called persistence volume claim. So first you have the virtual machine. Now you have created a volume on top of your virtual machine. So you have the volume and you have the pod. So how this is attached? How this pod is attached to your volume? So it will be attached using in between a middle layer component called as persistence volume claim. So this is called as request for storage. So this is your actual storage, and this is called your request to storage. Okay. For example, I need 5 GB of storage for my application. So your persistent volume claim will request for 5 GB storage, and then your persistent volume is your actual storage. Okay, this is just the request, so it's not the actual resource. The actual resource is your volume, so that only has your data stored in it. Okay, any questions? So your persistent volume is your actual disk or storage, and PVC is the request, storage request by your pod. So we will see how it will be used in real time for in your pods. So we are going to see that in the lab in detail, how it is being mounted. Okay. So any queries? So just understand the context. We'll explore in deep in the further slides. Okay. So there will be 3 fields in all the pods that we are going to see, which is volume, where your storage definition will be given, and volume mount, it will reside in your container. Okay. So there only your volume will be mounted inside your container. Whatever path you mentioned, it will be mounted in that volume. And there are a lot of storages, as I said. Empty directory is one of the type of storage that comes in the VM. So it's temporary storage onto the VM. Okay. So basically, we'll not use it in the production scenario, this empty directory, but for the labs, we can use this empty directory. So basically, whenever the VM is lost, this empty directory will go up because it is creating a folder within that VM. So if that VM gets lost, then you will lose the data from that VM. But for some resilient pods, this is fine to use until then the VM is lost. It's fine. So for some cases, we can use the empty directory. But for most of the production cases, we will go for other storage solutions like NFS, AWS EBS, Azure Disk. Yeah. So these are the actual production grade storage solution that has been used. Okay. Any queries? So I will start my lab. Let's see what we have there. So you can also do the lab in parallel. So it's under week 4, README file. So you can make use of the existing kind cluster, or you can create a new kind cluster from your previous lab. Okay. So this is so far we have seen deployments like this, right? So deployment file, its spec, number of replicas, and its labels, and then the container details. Okay. So far we have created an Nginx deployment without any storage. So that is how we were been creating it. So let me create it. I hope everybody is following, or so I want someone else to share so that I can explain on their machine to see if the lab works. Any volunteer for today?
Yeah, sure.
Okay.
Sure. Let me share my screen.
Yes, please.
Are you able to see my screen?
Yes.
Okay, let me just open the GitHub. So do I need to create a deployment, right?
No need. I have all the details. So you have to just use week 4 lab details.
Okay.
Okay.
In the demo app or
in the GitHub,
okay.
You will have the folder for week 4 lab.
Yeah, I saw that.
Okay.
So there is a folder consists demo app and the ISTO.
So open the README file.
Okay.
Okay, README file has the instruction.
Okay, okay, got it.
Create a deployment. I'm not able to see your README file. If you are sharing it, just
No, I'm not sharing. I'm just opening my VS Code.
okay, fine.
Yeah.
Maybe if possible, you can clone this repository and keep.
Okay, cool.
Because I have multiple stages of deployment.
Okay, okay, cool.
So first, we are going to see a deployment without any storage, and then with storage, how it looks and what is the implication of it. And then we will see what's the difference between static storage and dynamic storage. So that is what we are going to do that in the lab. And then meantime, I will switch to the PPT also, just to cover the concepts alone. But mostly this YAML should be enough to cover everything. Let's see. README. Yeah. Yes. So you have to apply this no storage. Yeah.
Okay.
And then now exit into that deployment. And then just yeah. So we are sending a message for on a file in that container. Okay, so basically this file will not be there if it gets restarted. Okay, pull up another, yeah. So now we are restarting the deployment, which does not have any storage into it.
Rollout means have seen this number. Yeah.
Yeah. So basically you can either delete a pod. So delete is a hard deletion. So it will not wait for any process to complete. Okay. So that's the difference between delete and rollout. Rollout means
safe restart.
Yes, it will take some time to stop all the process safely, and then it will restart your deployment. So either you can go for a delete or rollout restart. So that's what. So rollout restart option is available not only for deployment but also for stateful set, daemon set, and all types of
Okay, thank you.
So for all the three types, we have rollout restart. So in production, you must not use delete command. Safe to use rollout restart. Okay. So if in case if you do a force delete, then if there are some application that's connected to that pod, it will be terminated abruptly. So that might be an issue. So that's the reason that we are doing the rollout restart. So I purposefully added this command so that we discuss about the rollout restart instead of delete. Yeah.
I think it should be something similar to Jenkins restart and safe restart plugins. Plugins.
Exactly. Right. So what we have done, we have restarted that deployment, and again you exit into that pod.
Yeah.
And then check the file that we.
Okay, 1 second. Next.
So test.txt is not there.
Yeah.
So because we have echoed into the test.txt, right, on the line number 18.
Yeah.
So that file is not there.
Yeah.
So first we have created a deployment and then did a rollout restart of that deployment. I mean, written some content onto that deployment and then did a restart of it. So your whatever you have written onto that application, it's gone because there is no persistent, right? There's no storage attached to it. So that's the implication without having any storage. So this is clear, right? So this is our problem statement. We are going to address this problem. Right. So next, move on. So next step, what we are going to do, we are going to create a storage now and see what's the behavior.
Okay. Do I need to create it, right?
Yes, you have to. Yes. So basically, can you open that file? Static provisioning file?
Yes.
Yes. Right. So what it had persistent volume file. So basically, persistent volume object it created with a name called static PV, and then its capacity is 1 GB. Okay. So we have created a volume, 1 GB volume, and read write once means it at a time only once it can do a read and write, not parallel read and writes. So there are two types of access modes: read write once and read write many. So not all storage types supports these read write many. So few set of disks only supports read write many. So but for now we'll go with read write once. Okay, so that's access mode. You can just read about access modes and then see which volume supports access mode, read write many. So yeah. And storage classes, we have not specified any storage class. So it is, I think it will take whatever is there in the kind cluster, and then its host path is, so wherever we are scheduling, the pod is getting scheduled onto that machine, it will have this path mapped to this pod. It's just a directory. Okay. If the directory is not there, it will go and create. So that's called as directory or create. Okay. So it will create that, and then in that path, the storage the volume will be mounted. Okay. So this is your persistent volume. So the second file, which is persistent volume claim. So what I said, it's a request for volume to your pod, right? So it is also similar to your persistent volume. The thing is, you will not have the host path and all. So volume only has host path details. But here you are just requesting the storage, and then yeah. So 500 MI storage you need, and then its name you are giving. So whatever volume that's matching the storage, it will take it. Okay. So here we can either manually pass the persistent volume name or just leave it. So based on the storage match, it will check which persistent volume is available, and then it will map to the persistent volume claim. Okay. So you can either mention persistent volume field here or just leave it. Based on the storage size, it will match. Okay. Just come down. So first now we have created the actual storage and request to pod. So these two are independent, and then it is there lying there. How to access it in your deployment? So this is also one of your Nginx deployment. So the first few fields are same as that of normal deployment. So go to the line number 65. So you will see line number 65 to 71. So this is where your volume will be getting mounted. So which volume? So 68, just go and check the 68 line. So which volume you are going to mount into that deployment? So we are specifying a volume name called storage volume. And then on the line number 70, you will see persistence volume claim. So which volume we are adding? Static PVC, persistence volume claim. So you have to give the persistence volume claim name here, not the persistent volume. So it always should have persistent volume claim, not the persistent volume. Okay. So here we are mapping the persistent volume claim, and the persistent volume claim knows which volume to attach. So this is how you have to mount your map your volume, and then so now you have mapped the persistent volume claim, but it has to be mounted onto that container. So that configuration is there in line number 65, this volume mounts. So where it can be mounted in any path where you want to have. So we are mounting it in slash data. You can mount it in anywhere inside the container. So need not same as host path that we have seen it in the volume file. But yeah, so in any path, you can mount this volume. So now you go ahead and deploy. I think you have already deployed it, right? So now you can just exec into the pod. So yeah, proceed with the next steps.
Okay, okay.
Command also you can just copy it. Yeah. So
Okay, it's putting the logs. 1 second.
so basically we have generated the log. So this app generates the log by itself. So if you see the line number 61, I have just written echo command with the date and timestamp. Yeah, on line number 62 on the so date and timestamp, and then it is passing on to slash data slash app.log. Slash data is your mount, right? The mount path that you have mapped. So in that mount path, it creates a new file called app.log and then logging it. So now if you go ahead and restart, this data will be persisted. Okay, so yeah.
Yeah.
It's still there. So even before a minute log will still be there because of the data that is persisted using persistence volume. But there are chances that this data will also go off. What scenario do you think of? Like in which case this log will go off?
Oh, when the volume is deleted. So
So volume is deleted. When a volume will be deleted, like you are not by someone. So volume deletion can happen if a VM is lost, right?
yeah.
So in that case, there are chances that if we are just using the host directory, right? On the VM, we are just mapping a folder. So if that VM is lost, this data is lost. But for the sake of the demo, we are just using the local disk. Okay.
Okay.
So in production, what we will do, we will create a Azure disk or NFS volume and then map it to your VM. So it will be attached onto that VM. So it's not inside your VM. Okay, it's just attached to your VM, and then it will continue to persist even the machine is lost. So it will go and attach it onto another VM, and then it will still be there. So disk will be separately created. Okay, got the point, right? In the production, so we will handle like that. But the concept is we'll still create a persistence volume claim, and then you will map the persistence volume claim in your pod. So this is how the configuration will look like. So be it for any different types of volumes that we use. Okay. Yeah.
Okay. Then the volume create on the level of node or like any namespace is specific.
So volume is not created at the namespace level because namespace is just the virtual thing. So it's just for virtual isolation. So it's not the real resource. So your volume is your actual physical storage, right? So it will be on the VM level, not defined by the namespace. So basically, your question to answer your question, I think we can ask like the volume is attached at the volume is attached at the VM level, but your persistence volume claim is there, right? Persistence volume claim will be created at the namespace level because your deployment can be at the namespace level, right?
Okay.
So in this case, the volume is not a namespace scoped resource. It's a cluster scoped resource. So you cannot create a volume at namespace level. Okay.
Yeah. Okay.
So volume will always be at the cluster level. So you can, if you add, for example, do one thing. So if you add a namespace field into the volume, line number 8, line number 7, yeah. Hit enter, namespace. Yeah, any namespace. Yeah, fine. Just go ahead and create this. Just try to apply it again.
Yeah.
So do one thing, just delete it and then reapply it, because you cannot.
Yeah.
Yeah.
And also, I'm a little bit confused about the read light ones. So can you just give me the example, like
So
what
the
does
read write ones, and there are different access modes for this volumes. So one is read write ones. So you are not doing a parallel writes for the application. So it's read and write, read or write. So not by many applications. We are having only one Nginx deployment that's doing this. So if you have parallel writes and reads, then you'll have to configure read write many.
Okay.
So basically read write ones. So there are different types of access modes that are available in the volumes. So volume can be mounted as read write by only one node. Okay. Multiple pods can use it at the same time onto that node. For example, your database and Postgres, these can access using read write ones. But read write many, there is another access type which is read write many. So volume can be mounted by multiple nodes. Okay.
Okay.
Volume can be mounted by multiple nodes, and those are read write. So for parallel processing and all, you will go with the read write many. Okay, there is another thing called read only many. So even the volume will be mounted by multiple nodes, but only available option is read only. So you cannot do a writes. So based on different use cases, we can use these access modes. So basically for web pages like front ends, we can use read only. You don't need to write, right? So in that case, you can use read only many, right? So static contents, your web pages, for that you can use read only many. And for so most of the cases, it will be read write once. So your database, stateful set, all these will come into read write once. So the third one, which is advanced, is read write many. So it's for the shared storage, like your application is also doing a file uploads, okay, from many different sources, from many different medias, so many different content systems. So in that case, we'll use read write many. Okay.
Okay.
So it's not supported by all types of storage. So for example, if you try to create a read write many in your local disk, it will fail because you need a special type of storage to address that problem. So either you have to go with NFS or cloud file storage to support this. So not all storage types supports read write many. Okay.
Okay. Thanks.
Yes. So what did we do?
I think Swarna want to say something.
Yes, Varna.
No, Lavanya. I accidentally clicked on it.
No worries. So now you can create this volume.
Yeah, I have created and it shows.
So now you do one thing, kubectl get persistence volume namespace dev. So because this persistence volume is not even a namespace resource, it is a cluster scope resource. Just to, you can do kubectl get pv oyaml.
Kubectl get
pv
pv
hyphen oyaml. Yes.
Okay, it not mentioned the namespace.
Right. Why? Because namespace field is not allowed for the persistent volume because it's not a namespace scoped resource. It is a cluster scoped resource. But you can mention you can mention the namespace in the persistence volume claim.
Yeah, got it.
Yeah. It's because it's requested by your pod and your application is namespace scoped, right?
Yeah.
You can mention namespace in persistent volume claim and in your deployment. So in these two resources, namespace will be allowed. but volume, you cannot add a namespace to it. Okay. So
Okay.
it's not a namespace bound resource. So, so why it is meant to be like that? So volumes will be created by admins, but your application will be deployed by your development team. So basically, they cannot create a volume. Okay, only cluster admins can create a volume. They can only request the volume. If it is available, it's provisioned or allowed by your admin, then it will consume it. Okay, that's the reason why we have two different concepts called volume and persistent volume claim. So go up. So for example, I mentioned in the line number 2, so persistent volume will be created by admin. So in the bracket, it is administrator level resource. But for the persistent volume claim and the deployment, so these are, it can be created by your CD or your application team can create it with limited access. Right? They cannot provision the volume themselves. Just that they can create a claim and then consume it. So that there is also an RBAC, role-based access control, who can do what. So go to the next lab and continue to see. So now you have persisted the storage. Okay, stop here just a moment. Let me explain that for the next. I think we could have started the lab at the end, but I wanted you to parallelly visualize what I am saying. Then we can proceed with the rest of the labs. So so let's. So what we have done now. My machine is visible, right?
Let me stop my screen sharing.
Okay. Is it visible?
Yeah.
So what we have done now, we have created a persistent volume. We have created a persistent volume claim and then mapped into the deployment. So 3-step process we have done, right? So the process is create a PV persistent volume claim and then mount it to the pod. But in a real life, real use case, just imagine. So for each and every deployment, you will have to give this. So for each and every resource change, you would have to edit all these resources like persistent volume, and then you cannot just like that change the persistent volume size. So there is a specific rule that is followed, how you have to increase the volume size. So, and then you'll have to involve in manual process, and then scaling is difficult there. So because we are doing a manual job of provisioning the persistent volume by ourselves. Okay. So, but just for testing purpose, we can just use the static provisioning. So what you have done now is creating a persistent volume claim, and then mounting it in your deployment. This is a static way of provisioning. So in the real life situation, you will not use static provisioning at all. So then what will you use? So there comes in a concept called dynamic provisioning. So you don't need to provision the persistent volume at all. So it will create automatically. How it will be created automatically, I'll tell you how it does. So it will create the persistent volume by itself. So no need to have a admin to create a volume provision for your application teams. And then they just use the persistent volume claim and map it in their deployment. So we don't need to create a volume prior to them. So it on the fly, this dynamic provision handles it. So how it does? So basically in the application part, we'll still use the persistence volume claim, but the persistence volume claim is defined with a storage class. So another Kubernetes object that is coming into picture is this storage class. So this is doing the dynamic provisioning. So this will create the persistence volume behind the scenes. So we don't need to create it manually. So this will do the PV creation jobs. So what this will do, it will automatically create the persistence volume for you, and then your persistence volume claim will just attach it to your pod. Okay, so that is the flow of dynamic provisioning. Then how it, so the use case of dynamic provisioning is, of course, in all the production scenario, this dynamic provisioning is the one that will be used. Okay. So let's see what are the components that are there that are required for this dynamic provisioning. So first thing that I said is your deployment, that will still be the same. You still need a persistent volume claim. And then if you mention the persistent volume claim, it has to be there. So you will create a persistent volume claim with some access modes. So we have seen different use cases when to use what. So for most of the scenarios, we primarily use read-write ones. Okay. And then we request for some few, like how many GB your application require, you will request for storage. So one additional parameter that you will have to give with this dynamic provisioning is storage class name. So whatever name you give here, it has to have a storage class with the same name. So for example, if it's fast, just that should be a storage class called as fast, just for sake of demo. For faster storage provisioning, we can just mention that storage class called as fast. And then so storage, so it will go in the cluster and check the resource called storage class, and then the name is fast, and who is the provisioner. So either you will have to mention who is the provisioner, like is it a local provisioner? Local provisioner means kind cluster can create a volume. Okay. So the in our case, it will be kind cluster, but in the real production case, it will be Azure provisioner or GCP provisioner, NFS provisioner. So those provisioner details you will have to provide here. And then what type of SSD it is, premium or storage. So all the storage details, you'll have to provide it in the storage class. So this is the sample of provisioning a dynamic provisioning. So we'll continue with the lab, just a moment. So all three files you need. What is that? Deployment file, persistent volume claim. Instead of persistent volume, you need storage class this time. In the storage class, you will have to mention which provisioner you are going to use. Okay. So in it will be.
Is it a CRD, this storage class?
Yes. So these are by default provided Kubernetes resource. So in the API version, you will see storage.kh.io. You don't need to install anything for this. It comes in hand with the Kubernetes cluster. Okay. Yes, behind the scenes, it's a CRD. Okay.
So for AWS, like we have EBS drivers and EBS CSA drivers. Okay.
Yes. So this persistence volume claim will be bounded to your persistence volume. So the process will be, first your claim will be created. So the claim will in turn will automatically create a volume. How it will create a volume? Based on the storage class, it will create a persistence volume here. So if you see persistence volume will be bound to persistence volume claim. Again, it is one-to-one mapping. So you cannot have multiple mapping here. So one volume, one claim. Okay. So that's the binding. So if there is, if your storage class could not provision a volume, then your persistent volume cannot bind to your persistent volume. So it will be in unbound state. Then your application will not start because your persistent volume claim is not able to find the volume. Such error you will see. Okay. So in such case, you will have to just describe the volume and see what's the problem. So the end-to-end claim like process will be, I think again, we are going through the same, just for the sake of the concept understanding. So what we will do, cluster admin, as a cluster, we will be the cluster admins. So don't think someone else, we are the cluster admins. So we have to create a storage class for the application teams to consume. Okay, so we will create a storage class. And then what the application team will do, application developer, they can just create a claim, and then in the persistent volume claim, they will have the storage class reference. So if they have the storage class reference in the persistent volume claim, it will just go ahead and then create a persistence volume, and then it will be attached to the volume. So how this is all done? It is done by persistent volume provisioner. That's mentioned in the storage class. So this guy is going to create my volume automatically. All that you have to have is the persistent volume should have which storage class. The storage class in turn will have volume provisioner, and that will create a volume for us. So in the application part, so user does not know what happens behind the scenes. All that they see that their volume will be mounted and then it will work as is. Okay. So behind the scenes, we will create a storage class for them. Okay. So now you know the difference between having a static and dynamic storages. So the clear difference is in the static provisioning, you will have the volume, persistent volume claim defined, and then persistent volume claim details will be passed on to the deployment. But in case of dynamic volume provisioning, you don't have the volume, persistent volume file. Instead, you will replace it with the storage class. So now I have a question. So I have application team 1. So they have created, for them, we have created a storage class. So they created a volume and then they deployed it. So the second application team comes in. So what are the 3 files that you will create for them? So what are the files that you will create for the second team? So first team, you have created a storage class, persistent volume claim, and the deployment. And for the second team, what will you create?
Yeah, it will be same. The storage class name might change.
Okay. So do you think you will create a storage class for every team?
No.
Not required. Because we can just use a single storage class and then use the same storage class to provision volumes for each and every team. For example, if some teams, so they want a disk storage type, we can just create one storage class for them, for the disk provisioner. Okay. So for that type, you can just create one storage class, and the same disk storage class can be used across all the application teams, whoever wants to consume the disk storage type. For example, if some team, they want a file storage. Okay. So there is a storage type in Azure called file storage. If they want such storage type, then do you think you can reuse the same storage class? No, right? Because it's a disk storage class. So in that case, you will have to create another storage class called file storage class. So just name it like file storage, and the first one is disk storage. So first time you have created a disk storage, and now a new requirement comes in for file storage. Now you create a new storage class called file storage, and then consume it can be consumed by any application team who want such type of storage. So the answer is, based on what type of storage they need, you can just reuse the same storage class, or you can go ahead and create a new storage class. So this storage class creation is not in day-to-day operation. So you just create once in a while, just create based on what storage needs that your application team has, and then just forget about it. So that's so it's not your day-to-day operation. So during the design, you just create it, and then just that they can reuse the same name. Yeah. Clear, right?
Yeah, if there is single storage, how do they access the files, or like they access via paths, different paths in the storage once it is allocated? Two different applications.
So 2 different applications. So here we are not saying about the local storage onto the VM. So you are saying about in the real production case, it will be a disk storage attached to your volume. Sorry, attached to your VM. Okay. So team A will have disk A. Team B will have disk B attached to the machine. Okay. It's not the directory onto that machine. It's a disk attached to the machine. So see the difference. So a separate entity attached to the machine. If the VM is also lost, still the storage will be there, because it's a disk that's available. It can be attached to any VMs.
Okay.
Okay, it's not the directory. So just for the case of understanding the concept, I'm just giving a empty directory or host path in our example. But in real use case, it will be a disk or file storage that's attached to your virtual machine. So it's not the directory. Is it okay?
Yeah, yes.
Yeah. So now let's see what are all the external storage options that are available. So yeah, I think we have discussed most of it already. NFS for file, it's a file storage. And then AWS EBS, Azure Disk, and Google Persistent Disk. So all these are block storages. And then yes, SAFE is another external storage option that's available. And then NetApp is also providing enterprise level storage. So these are our different types of storage options. So in the storage class, you will have to mention which provisioner we are using. So if it's an Azure provisioner, you will have to mention it as an Azure provisioner. So each and every type of storage, they will have a different provisioner option. So based on that, we are controlling it. So it's not the local storage. As Abhishek rightly pointed, it's not going to be on the same virtual machine. So it's going to be an external entity. Okay. So just revisiting again. So pod will have volume, and then it will be mapped to a persistent volume claim. Persistent volume claim will have the storage class name. If it's AWS provisional, AWS disk will be attached. Google provisional, Google disk will be attached. Azure disk will be attached to the virtual machines. Okay. So it's all a different storage options that are available. Okay. Yeah. I think that's it. We can continue with the lab. Priyanshu, you can go ahead and share.
Oh, yes, sure. So, like as I just checked the storage class, so by default it is using the Rancher local path.
Yes, the kind cluster that we are spinning up, it by default comes with a storage class. So which is a local path onto the Docker container.
What is Rancher like?
Yep, Rancher is one of the provisioners. So the so basically Rancher is a tool. Okay. That will provide a local path as a provisioning option in kind cluster.
Okay.
Okay. So it's Rancher dot. I don't be confused with the Rancher. So it can just consider it as a local provisioning path. That's it.
Okay.
So the kind cluster it comes with its own wrapper of provisioning the volume, the local volume using rancher.io. Okay, basically nothing but the local provisioning, basically you're creating a directory or a path onto the Docker container. But the wrapper it uses is the Rancher. So I'll tell you about what is Rancher. So don't get confused. You might have seen this Rancher somewhere else. Rancher itself is a tool to manage Kubernetes cluster. So you can create a cluster from Rancher.
Yeah.
You can manage the cluster from Rancher. So you can create and manage cluster operations from Rancher itself. This kind cluster is using that Rancher wrapper to provision the local storage. Okay.
Okay.
So Rancher itself is a different tool to create and manage the Kubernetes cluster. So it was a famous tool in on-prem to manage a bunch of clusters. So it was widely used. Even now also it's being used to manage the cluster and cluster operations.
Okay.
Okay.
Do I need to create the dynamic provisioning?
Yes.
Okay. Do I need to zoom in my screen or like comfortable?
Yeah, it is visible.
Okay.
Continue.
Yeah, so I've just run this command like kubectl get PVC.
Okay. So you will see the storage class name as standard, right?
Yeah.
So do one thing, just to go back to the dynamic provisioning file, we'll see it from here, and then we'll come back here and see it again. So here we have mentioned the persistent volume claim, and then come down for the application. So come down. Yeah. So here just we have mapped the persistent volume claim. So I purposefully missed out the storage class. Why? If I don't mention any storage class name in the persistent volume claim, whatever the default storage class it's available, it will take. Clear? Now can you just OYAML the storage class name here? Kubectl get storage class.
Okay, okay. This one. I
Yes.
already got it.
Yes, yes. So now if you see here, I did not mention in my PVC to take the storage class name, right? I purposely missed it. So if you miss it, even your application team, they do not know the storage class name, it's fine. So whatever the default storage class that is mentioned, it will be taken. So in the annotation, you will find something called is default storage class. Just go up one more line. Up. Yeah. Storage class. Yeah. Come down under the annotation.
Okay.
Next. Yeah. So is default class is true. So if persistent volume claim does not mention anything on the storage class name, it is going to use whatever is the default storage class. In my case, the standard is the default storage class. Okay. So it's using this storage class and provisioning the resource. Okay. So now you can go ahead and complete the lab. So basically it is going to retain the logs. That's it. We have already seen it like persisted storage. So just that we are using a different provisioning method.
So I have a doubt. So in cloud, will it be the cost of that storage usage will be accordingly how much we'll use? Like how?
So in the persistent volume claim, you will mention the size, right? How much you need.
Yes.
So the cost of the disk is based on the size that you define in the persistent volume claim. Okay.
What if we need beyond that?
So for example, if I have 5 GB requirement on my application today, okay. Tomorrow my application size increased. Do I have to go ahead and then increase it to 10 GB? Not required, right? So there is an option called as resize persistence volume. So if you enable that, it will automatically grow.
Okay.
Unconditionally, it will grow. For example, if you start from 10 GB and you increase it to 100 GB, your application size has increased so that your storage is also increased. So it can increase to 100 GB today, and then it can go on and increase to TBs as well. So where is the cost? So you have to ensure before resizing it, and you have to have a cap, like up to 500 GB or something, it can resize. That's it. So you'll have to have a cap. Otherwise, your cost, cloud cost will increase. The storage cost will increase.
Yeah.
Okay. So to reclaim the storage, you will have to do the cleanups. It can never increase forever, right? So in that case, if it is a TB size of application, this storage is not your solution. You'll have to use some database to store it, right? Yeah,
Yes.
NoSQL DB or SQL DB, whatever your application needs, you will have to ship the data there. So it should not be your disk that keep on increasing. You
Okay.
have to have a solution for it. So that's why we have databases. Yeah, provided by clouds, and sometimes we manage it ourselves, right?
Yeah,
So
yeah.
those will come into picture.
Yeah.
So the data is persisted, right, Priyanshu?
Yeah.
Hmm?
Yeah. Data is persistent. I check.
Okay. Yeah. Basically, we will see the same situation that we have seen it in the static provisioning. The only difference is that it used storage class to provision. So do one more thing, kubectl get PV. So basically, if you see the status field,
Status, yeah, bound.
bound means it is bound to a persistence volume claim. So you just create a claim, sorry, you just create a volume, and then without creating a persistence volume claim, so there will not be any status for that volume. So it's unbound. Okay, it is lying around without any use. You should not create such volumes and then keep lying, like storage is wasted there. So you'll have to reclaim that space, right? So there comes in a concept called reclaim policy. Just to in the kubectl get PV, before the bound, you see something called as reclaim policy. Yeah, here, reclaim policy. Upon deletion, it will reclaim the data and reclaim the storage. Okay, so 1 GB storage will be reclaimed if a pod, if a deployment is deleted. So now if you just delete the deployment and then see what will happen, it will delete the persistent volume claim also. So and then your volume will be reclaimed. Reclaimed means this volume can be used by any other application. Okay, retain means for some critical application, you want to retain the volume so that it can be attached to any other application. So and then consume the same data. So in that case, you have to use reclaim policy, retain, and then for delete, so for non-critical data, you can make the reclaim policy as delete. So you have to decide based on your application needs. And the capacity, you have to mention how much you need. Okay, and then you can increase it. So we prefer to increase it manually, not by just increasing it dynamically forever. So just if there is a requirement, you will have to have a alerting mechanism. So if the volume is full by 90%, you will have to have some alerts configured for the volumes. So if it's reaching the 90%, you will have to evaluate and then you will have to increase. So increase just 10 or 20%, not 100%. And then evaluate with the application team, do they really have to increase this forever, or there is an alternate mechanism to fix this? Okay. So we do this manual size increase. Okay.
Okay.
Start of the application to rebound it. Yes.
Yeah, I have one question. Like as we create the persistent volume claim, okay, and we are using the host like volume, okay. So if we check our storage class, so it mentioned the rancher or local path, okay.
That's also the local path, right?
And volume bounding mode is waiting for the first consumer. We already created the persistent volume and the persistent volume claim. So why it is also showing the waiting for the first consumer?
So this is not at the volume level, right? It's at the storage class. It's a storage class setting. Okay. So when you create a persistence volume, claim, okay, it will not go ahead and bind with your volume. So it will wait for the pod to consume it. So when the pod is getting ready, that time only it will be attached.
Okay.
What it is, wait for first consumer means wait for the pod to attach it to your PVC. So if there are no pods, then it will not attach. It will still wait for the first consumer, which is your pod.
Okay.
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 Yeah. I think we'll try to wrap up with the role-based access control. Okay.
Okay.
Yeah. You can unshare. I'll take control. So
Yeah, 1 second. Yeah, you can share this.
Yep. So let's go to the next concept called role-based access control, which is very important when it comes to accessing the resources, right? So far, we have never restricted any access. So anybody can access any resource. There is no such restriction in place for applications up to now. So now we are defining which user can access what resource. So what's the permission? So we are going to deep dive into the role-based access control. So what is the user and what is the permission and what resource they have? Only that type of resource they can access. Okay. So what do we achieve with the role-based access control? We'll have a more secured cluster. So we know who can access what. So not everyone can just go ahead and delete the deployment, right? If you provide excessive application access, then what they will do? They will log into your cluster and then they will run the kubectl command. They can delete the deployment even in the production as well. So then your application will be down, right? So you'll have to ensure that right person should have right access. So that's where this role-based access control comes into picture. So we'll have to protect the critical resources. So they can even delete the node, the kubectl delete node. It's all simple commands. So anybody can just Google it and then run the commands. Yeah. So we have seen it like multiple teams. They go ahead and delete the namespace unknowingly. Unknowingly without understanding the impact, they just delete the namespace, considering it will not delete anything. But what will happen? Underlying thing is all their application will be lost. So not only they can delete their own namespace, they can delete other teams' namespace as well. So which is very critical, right? Which is a very production outage scenario might cause if they have access control. So always there is a concept called as minimal access. So that's what we have to follow. Provide minimal access. If they need access, revalidate it and provide excessive access for that team alone, only onto that resource, not for the cluster level resource. So how it will be achieved? So we have something called as role and role binding to achieve this access. So how it will be done? So I have a user. So I have a role. So in the role, I will define what are all the rules. And then in the role binding, I will allow that user to have access to that resource. So I will show you how a role and role binding will look like. Just understand the concept like you have a user and then you will define a role and then you will do a role binding like which user will have access to which resource. So that's it. That's the underlying concept. So this role and role binding is a namespace scoped resource. Okay. So you can define a namespace field in the role and role binding. But what happens if there are some users who need cluster level access? So there comes in cluster role and cluster role binding, where namespace restriction is not possible. So for application teams, you always consider giving role and role binding. So for any application which needs only namespace specific resource access, you'll have to start giving only the role and role binding. If some application team or you have a DevOps team as well, if they need excessive permission, then you can consider giving cluster role and a cluster role binding access, which means they can have cluster level resources permissions. So for example, they can list all the namespace, which is across all the which is at the cluster level, you can display all the namespace and the nodes. So these are cluster level resources. Okay, such access will be provisioned with the help of cluster role and cluster role binding. So this is also similar to role and role binding. The only thing is the role and role binding is namespace scope, cluster role and cluster role binding is cluster scope. Okay. So let's see how it will be done. So not only to the application team we will restrict access, so we can also restrict the access to the service account, which is system account. So far we have talked about the user. So who is the user? So either you, me, we are all users, but we are all real users. But there is something called a system user as well, which is service account in Kubernetes world. Okay. Service account is a system user. Your application team will use the service account to authenticate. Okay. So that's another type of user. So you can create a service account and then map that cluster role or role to that service account and then use that in your application. Okay. You can do that for the service account as well. So now you know the difference between role and cluster role, right? So let's go to the lab. Priyanshu, can you share?
Yes.
So just understand the concept. We'll deep dive into the lab, and then we'll see what's the role and role binding.
I understand the role and role bounding, but confused on the service accounts.
No worries, we'll check it now.
Okay, cool. This is already created. Do I need to delete the dynamic provisioning?
No, leave that all. That's fine. Then
Okay.
independent, it's fine. So now open the role binding file.
Yeah.
So
Yeah,
what we are doing, we are creating a namespace called dev. Okay. And then we are creating a role. What is a role here? So we are creating a role called a pod reader in namespace dev, line number 18. Okay. So we are creating a pod reader for the namespace dev. Since it is a role, we'll have to map a namespace always. So what API groups, what resources it has to have access on the pod? What are the permissions? Like what are the verbs? Verbs means what type of permission, like get, list, watch onto the pods. So for core resources, it will be empty. So line number 20, it will be, if it is an empty, then it is core resources. Pod is a core resource. Volume is your core resource. Means that's the smallest unit. Okay. So this pod is the smallest unit, right? Similarly, your storage is your real application, right? So those are core units. So that's why you are having empty. For deployments, it's apps/v1. So how you will identify those things? So in the API version, line number 14, go to the line number 14. At the end of the, so you see v1, right? So v1 means core resource. And apps/v1 means that's your deployment and all will fall into that API resource. So we will see that in the upcoming resource. That's fine. But just one activity that I want to give, just go ahead and then understand what's the difference between core resource, deployment resource, storage resource. Each and everything will have a different API version. Okay. So just understand that concept. So core resource, storage, and then network. Just evaluate, just go ahead and then do that activity and then come up with some question in the next session. Okay. Maybe tomorrow we'll discuss further. And the role binding. So in the role binding, basically what is it has to have? It has to have a reference to role and which user. So role binding is nothing but binding the role and user details. So in our case, the role binding is for the user, dev user. Okay. Line number 36. So this is for that user. So you can give the access to user, groups, and service account. So 3 types of the subject access you can give, either user or group or service account. So here you can mention which type of resource you are giving access to, like which type of resource and which type of user you are giving access to. So you are not going to give for every user, you cannot create a role binding, right? So in production case, you'll have to always give group user, like you have to mention dev group, and then add all the dev members into it. For example, if there is an application name called HR, then HR group will be there, HR team members will be part of it. So once you define the role binding for them, that's it. You don't need to provide access to each and every user. So whoever part of that HR group, they will have access to their application. So all that you need to do is add member to that AD group. That's it. They have access. So every time if a new team comes in, you just add once that group in the role binding. That's it. So upcoming access will be managed by that AD group. Just add member to that AD group. The access will be sorted already. So they will have access, respective access that the application team needs. And then role is the pod reader. Okay, so that's the role and role binding.
So role we can consider as a policy where we decide like dev user and pod user will have these kind of access, like right?
Forget about the user. User will not come in picture at all in role. Role is nothing but what is the resource. Okay, just imagine role as resource. Which resource? Pod. Pod is a resource, right? Comma, service. Service is a resource, right? So whatever kind that you give.
Okay.
Okay, deployment is a resource, right?
Yeah.
So role is nothing but resource. So, but what type of access that you will give, like get, list, watch, or all the verbs. So you can run kubectl get command. Okay. Kubectl get pods -watch is the watch command. Okay. Kubectl logs. If you give logs, then they can view the logs. So these are called different verbs that you action onto that pod resource or delete. So any CRUD operations will come into picture here. Like role means which resource and then what action onto that resource. That's called role. Role binding is the one that maps role to that user. Okay.
Got it.
So just go back to the cluster role and cluster role binding YAML. There is another YAML here.
Yeah.
So here, as I said, this is scoped to cluster. Okay. So similarly, this is also on the pod level. So get, list, watch are the actions that we do on to that resource. And then again, cluster role binding for the user. Which user? Cluster user. They can do get, watch, list on to the pod. Okay. So I will give a assignment maybe tomorrow to explore few more roles, and then so I will ask create a role or role binding for deployment. So they can only view the deployment. So they cannot delete a deployment. Then you'll have to write a cluster role for it, cluster role or role based on the scenario that I give, so that you will explore end to end on this cluster role and cluster role binding. I will also give you a scenario for service account. So you will create a service account and then you will define and you will see the difference. Okay. So that assignment I will give. But for today, I think we can stop. Maybe we can continue 15 minutes tomorrow and then finish this up. And then I'll give an assignment so that you can explore further more and then we can discuss further. Okay.
Yeah. One question, Lavanya. Here, cluster user, cluster pod reader are the usernames, right? So are these the IAM users that we create, or do we create users here through the YAML, I mean like manifest files?
Not create. So these users that are the users groups are not local users or groups. So in production, so for kind cluster, we are creating a user. But in real production case, it has to be user from AD group or IAM.
IAM. Okay. Yeah, thank you.
So you cannot manage the list of users. So, but there are possibilities like you can import a CSV user, but no use, right? You'll have to have a MFAs for that user to access. So you have to have an external mechanism. But that's technically possible. But in production case, it has to come from the Azure or IAM.
Yeah, got it. Thanks.
Yep. I think we'll continue tomorrow since it is already late. Okay.
Okay.
Thank you, team, for joining in.
Thanks,
Saturday.
Lam.
Thank you.
Thank you.